Hi, I'm Max Jablanovsky. Along with my teammates Sophia, Jordan, and Alyssa, we assisted MECCO with their manufacturing of U model lasers. MECCO is a small company located in Cranberry, Pennsylvania. They began in 1889 as a manufacturer of ball-peen marking technology. In recent years, they have transitioned into the laser marking market and are now a leader in marking and traceability. Currently, they have demand for about 15 U model lasers per month, with double-digit sales growth predicted in the coming years. MECCO asked us to help with their U model assembly process. Right now, their documentation is a 12-page manual. They have one technician who makes these models, and a full assembly takes about 4 hours. These factors make it difficult to meet common fluctuations in demand. We met with two MECCO employees, Martha Fegan and Andre Hetman. They asked us to transition from a pull system where lasers are made to order to a batch job hybrid process. They also wanted to enable less experienced technicians to contribute to the U model line. After observing their current process, we also identified areas for improvement in part organization and workstation layout. MECCO's current U model documentation is an assembly manual about 12 pages long. Here's one page to use as an example. In this manual, parts are not listed by assembly, and the instructions assume that the technician is familiar with the U model. It is also difficult to identify parts and what they look like. Using their assembly manual and our interviews with Joe Bean, the U model technician, we decided to separate instructions into the 5 basic subassemblies common in every U model: the controller chassis, the front panel, the power supply, the rail chassis, and the rail cover. New work instructions were created for each subassembly that clearly identify and describe each part, as well as mark and reference part numbers throughout the text. Once we separated the total assembly into 5 subassemblies, we identified opportunities for material handling as well. Here are how parts are currently brought to Joe's workstation. All of the parts are grouped together on one cart. They are mixed in different boxes, not separated by subassembly. When Joe makes a laser, he does it start to finish. We went into the inventory cage and borrowed a cart. After trying different approaches, we arrived at the result you see here. With this new process, subassemblies are separated into kits. Each kit makes one subassembly, and the finished subassemblies can be stored on the rack for future use. After testing the new cart concept, we realized that the current layout was not conducive to manufacturing U model subassemblies. All assembly is done at the technician workstation, and some space is underutilized. Measurements of the existing layout, workbenches, and rack storage were taken. We also recognized some constraints for this space. The aisles must be wide enough for technician movement. Other models of laser are made at the technician workbench, and some of the existing fixtures were too big to move. Within these constraints, we wanted to create a new subassembly workstation. A new table could be located in the work area. Additionally, our subassembly racks could be stored nearby for easy access. Finished lasers could be stored in an unused corner between 2 doors. Finally, this new layout requires minimal relocation of heavy fixtures, maintains aisle width, and does not impede work done at the existing workstation. For our results, we analyzed 2 scenarios: a weekly demand of 4 lasers and weekly demand of 5 lasers. It is important to note that these calculations are based on current estimated demand, as well as assembly times provided by MECCO. We found that on average, an experienced worker like Joe would be 1 laser short per month. This figure increases to 4 lasers per month for an inexperienced worker. In the case of a weekly demand of 5 lasers, an inexperienced worker is short 5 units per month, while an inexperienced worker is short by 8. However, the proposed changes to work instructions, a standardized assembly process, and kitted parts mean that workers can now be cross-trained for U model production. This means that over the course of a month, additional workers can be assigned to work on subassemblies, freeing up experienced technicians to complete the lasers. By smoothing out the labor requirements, demand can be met by simply reassigning existing employees. Some of the improvement from this project is difficult to measure. New technicians will more easily understand their work instructions. This means that MECCO management can reassign technicians to the U-model line, resulting in labor flexibility. Because of this, they can now respond to increases in demand. Our measurable improvement was also significant. The proposed layout decreases unutilized space by 11%. Switching to a batch job process will save about 20 minutes per laser. Finally, the percentage of value-added steps was increased by 3%. The work instructions that were created can be used immediately without any changes to the material handling process or the existing layout. These should be printed, laminated, and stored at the existing workstation. Additionally, these instructions should be color-coded by subassembly. The proposed workstation can be created by modifying the work area layout and purchasing new equipment. It requires one new table, modifying 2 existing carts, and purchasing 16 bins for parts. Each bin should be color-coded by subassembly, as seen below. Finally, production should transition from a pull system to a hybrid batch process, where 4 sets of subassemblies are created each week. This work could be done by inexperienced workers. The material handling process should follow these changes by creating 4 of each kit per week and outfitting the carts to separate subassemblies. Each rack should also be color-coded. We would like to thank Dr. Lankesorn for his advice throughout this project, Dr. Haight for lending us his industry experience, Joe Bean of MECCO for his thorough explanations of U-model assembly, Andre Hetman for his devotion to helping our team succeed, and Martha Fegan for helping us focus on the deliverables.